Good afternoon, everyone. Thank you for joining. I for sure have taken quite a few lessons from this conference so far. I think really some eye-opening presentations in the first yesterday that I saw, especially that one by Professor Marinos. Amazing the level of presentations that we have here. So thank you to all of the speakers so far. So I think Corinne's introduced our panelists. Let me just get this up. So our discussion is about, it's actually shown there, integrated dewatering and ground improvement, optimizing methods for construction below the water table. So luckily enough, we're blessed with a panel of 3 hydrogeologists here and geotechnical engineer as well to guide us. So I think it's going to be a very productive panel. So I think if I could start ladies first, Savi. If I can ask you, what is the relationship, would you say, between the shoring system and the dewatering system?
Hello. Good afternoon, everyone. First of all, I want to thank Mr. Korean and Dr. Marwan and Dr. Ahmed Garib for giving me this an opportunity to be as a panelist in this professional DFUI platform. Thank you, all of you. Yes, I just want to tell you that shoring and dewatering system is not considered as an independent element. They are function of an integrated excavation support system. The primary role of shoring is to support the lateral excavation, whereas the dewatering system is to control the groundwater and lower and reduces the effective pressures, pore water pressures on the excavation and the shoring system. So without adequate dewatering, the shoring system must resist not only the earth pressures, but also the hydrostatic stresses, which increases the lateral deflection, bending moments, and anchor loads on the strut and the anchors. Again, conversely, excessive dewatering will also have an impact on the excavation in terms of drawdown and excessive settlements outside and inside, and the stability of the shoring system sometimes. So therefore, I say that shoring and dewatering system should be studied together, because dewatering system influences the earth pressures acting on the shoring. The shoring system influences the groundwater flow and the seepage. Both shoring and dewatering impacts the ground movements, affects the ground movements and the settlements. The overall stability of the shoring of the excavation system depends upon the ground condition and groundwater and the structural support system. Therefore, I always say everyone that shoring and dewatering system should be studied as one geotechnical solution rather than 2 different elements. Thank you.
Yeah, I think that's actually very true. One thing that I can think of now, just working on various projects, there's definitely, I think I've heard it in a few of the discussions now, but there's definitely, we should focus more on basically the contractor, the design engineer, the client, all working together. And, you know, it's more complicated even when we talk about, let's call it shoring and dewatering, because you can have a main contractor who's doing the piling or the cutoff and the ground improvement works, and you can have a specialist dewatering contractor, and they're separate entities. So I think there has to be a focus on the design engineer who designed the wall, the dewatering contractor, and also the piling contractor, all talking together, ensuring that, for example, the wall is deep enough. Yeah, so I think we can elaborate later on that one. I just want to ask Savi another question I have here. What will happen if the deep well toe is placed below the shoring toe?
Yeah, good question. Yes, if you put the deep well toe below the shoring means you are pumping excessive water below the shoring toe, which will have impact outside which will cause the drawdown outside the plot, and which potentially increases the settlements outside the plot, which can have impact for the adjacent structures, utilities, and the shoring system itself. The key question is not the shoring toe kept below, deep well toe kept below the shoring toe. It is, we need to understand the regime of the groundwater flow. What adversely impacting the passive zone and inducing the excessive settlements and adjacent structures, utilities, etc. So this can be assessed by proper integrated study of dewatering and shoring design, taking into the consideration of seepage and support system. So I always prefer that normally, in order to achieve proper drawdown of 1 meter, drawdown below the excavation, normally we have to, the deep well toe should be kept like approximately 4 to 6 meters below the excavation if you want to achieve 1 meter drawdown as a thumb rule. So dewatering has to be taken care, because shoring act as a cut-off wall. So if the shoring toe is not sufficient and we keep the deep well toe much below the shoring toe, what it means that horizontal flow of water is 10 times more than the vertical flow, means K of horizontal is more than 10 times more than vertical flow, which will have impact within the plot and outside the plot. Thank you.
All right, thank you very much, Savi. I think I'll open it to the rest of the panel. Podrick, Oliver, do you want to maybe add something there? Maybe I'll go for Podrick.
Thank you. First of all, it's a pleasure to be here. So thank you for the UFI for the invitation to participate in the panel discussion. To add to Safi's comments, they can't be separated, shoring and dewatering design. I think the point we'd emphasize and we see commonly is anything that's deep underground tends to be critical path or critical risk on the project. Often the design considerations and incentives for shoring are they're different to those of dewatering. In terms of the perception of competitiveness and enabling a contractor to make a decision. Integrated design and risk profiling of the works, I think, is incredibly important to protect ultimately the project. That's the agenda. We're here to facilitate construction. So it's protecting program, protecting the project. We've, within the room, and I've seen today and over the event, there's an incredible amount of experience in the market. It's shoring, grouting, soil improvement, dewatering capability. All of this is contributory to design considerations. And I think it becomes a hybrid consideration how we optimize both shoring and dewatering design. Maybe Oliver.
Thanks. Oliver, next. All right. Yeah, I think we're a bit limited on time today, so all right. Just have a look here. So our next topic is evaluating the environmental and economic trade-offs between temporary dewatering systems and permanent cut-off methods for construction of deep basements in highly permeable saline coastal fills. Yeah, it's quite a challenging subject, that one. Oliver, maybe I'll take it to you now. So variable, heterogeneous, deeper conditions, and the risk that they bring, right? If we talk about the ground model, the ground conditions. Can you elaborate a bit on those risks, and then maybe the value of having a good ground model? I mean, that's especially from the different talks I've seen, and in many presentation after presentation, I see if a good ground investigation wasn't done, you know, you typically pick up trouble. So I just want to see the last part here. Yeah, maybe a good geological model depending on the kind of project, and yeah, let me ask like that.
Yeah, I think you know, Dubai and the UAE present you know, some very specific and unique ground models. You know, this morning we had speakers talking about the crushability of carbonate sands, for example, in Palm Jumeirah. And you know, it's great to have that knowledge there, because obviously you have Palm Jebel Ali, which is, you know, going to be developed over the coming years, and to have that basis of knowledge now is fantastic. So, in terms of dewatering, some of the experience that you know, we've seen for on Palm Jumeirah, let's say you have broad, shallow excavations, maybe one or two basement levels, but if you look at the specification, the soils are considered to be silty sands. I think that was also discussed, but the reality is that how these materials were placed has led to some heterogeneity, right? You have some working platforms within there, and these kinds of things can throw up enormous heterogeneity, and that affects the hydraulic conductivity, the permeability. So to go to an example that I've worked on the crescent of Palm Jumeirah, a hotel foundation was excavated one basement level deep, partly seek piled, and the rest was controlled by deep well dewatering. And all of the information, or most of the information, had indicated that this was indeed a silty sand, but as we looked at, you know, and I think geostatistics was a subject that came up this morning as well. When we looked at the entire amount of particle size distribution information, we did find that there was a sort of fat tail at the end of the bell curve, which was leading to certain areas of high hydraulic conductivity. And ultimately, this made very challenging dewatering conditions, even though it was a shallow excavation. Your proximity to the sea and the perimeter of coastline close by on both sides of your excavation made it, you know, means there was really no margin for error. So ultimately, there had to be a change in design from pure deep well dewatering to include sheet piling, which, you know, was a very effective solution. So I think the lesson is that you know, in such conditions, you have to be very sure indeed with your site investigation. It may miss things no matter how thorough it is, and understanding that ground model and that conceptual model of how the material was placed is a really important consideration. When we look at the ground models for, you know, as Dubai is building further inland and Abu Dhabi further inland as well, you have a completely different ground model. You have natural conditions, and as we deepen our excavations, for example, with these large tunnel or high-speed rail projects, you have a much more variable geological regime. So, whereas we in the upper layers we usually have either sand dune or fill or aeolian sand, cemented aeolian sands. As you move down into the deeper layers, you often get that heterogeneity of conglomerates. And as a hydrogeologist, we see that these are massively preferential flow paths. Quite difficult to pick out just from a geological log, and can cause a lot of heterogeneity over small distances. That also, goes back to having a good site investigation is obviously super important. When you look at the deeper conditions in Abu Dhabi, those are different again. You have the layers of gypsum in with the siltstone, which as a hydrogeologist you also start to understand that those are soluble. If you start to get piping failure, you can lose some of those layers. They can also be a confining layer, so you can end up with some artesian conditions because all of these flow systems are interconnected to areas far outside the plot boundaries. So again, these are the considerations, outside your site boundary and the importance of that ground model. One of the other points I wanted to talk to you about that really was, I guess, the pumping test, I think, is something that hydrogeologists and I think a lot of dewatering contractors are passionate about. We're all familiar with packer tests and falling head tests, and these only test a very small part of a very small volume of your site around your borehole. The pumping test will target a much larger volume of your excavation, and it'll start to intersect that flow network. So it's very important to stress that it's very important to stress that water table to start to understand how a dewatering system will actually behave once it's installed, and the pumping test is really the gold standard way of doing that. Pumping tests are, they're a more expensive option than your falling head test or your packer test. They require pretty careful supervision and interpretation, but they, I think the lesson from mega projects in Doha and Saudi Arabia and Dubai is that they really are an excellent way to reduce that risk of projects.
Thanks, Oliver. That's definitely. I couldn't agree with you more. I see a lot of the projects. They basically just specified falling head tests, packer tests, and even if the project's purpose or a large part of the project is about deep basements, they will have shoring, they will have cut-off walls, they will have dewatering. They haven't specified pumping tests, so I think even for ourselves, we are looking more into specifying pumping tests. They are more expensive, but they definitely provide value. Just for the sake of time, I'm going to move on to the last topic we have. And then, Podrick, I know you had quite a few things to say also about pumping test. So maybe at Q&A we can try and work that in. So topic 3 is about leveraging real-time piezometric monitoring and numerical modeling to anticipate and mitigate potential settlement risks on adjacent structures caused by water table fluctuations during deep dewatering campaigns. It's quite a mouthful. But Podrick, if I can ask you maybe from your experience with Action and the technology that you're implementing, the monitoring, instrumentation and monitoring that you often have to do, can you elaborate a bit about that and maybe some examples?
Yes, I think first of all it's a very dynamic and exciting time in the industry. We're seeing a lot of advancement in softwares, telemetry and our ability to capture data in real time. The foundation of kind of telematics and monitoring, I think it goes, and we encourage it. It goes back to the investigative stage and the ground model. One challenge that's faced, and we face often, is that the geotechnical information we receive is limited to within the plot boundaries. So the ground model itself is an extrapolation of very limited data, where we really want to have expanded ground models within which we're simulating the dewatering condition. Data today, and we've a lot of use. We've been working with telematics for about 15 years, where we've got real-time data which we can calibrate our numerical model. So it becomes a digital twin. More notably in the recent years, and I'll use Neoma, the Marina Basin, as an example. We had over 2,000 telematic devices reporting in on a single platform with full data visualization, and that was feeding a numerical model which was calibrated on a weekly basis. First of all, it provided an incredible amount of data over time, which in itself acted as a predictive model for any future excavations or dewatering schemes. Today, anything that can be measured can be reported and visualized in real time. So that can expand from, if you look at it on a dewatering regime, would be flow, pressure, water levels, water quality, any asset performance, and then we've got settlement. So whether it's settlement sensors, inclinometers. So this full suite of data capture can actually be visualized, and preventive action taken. If you get any indication of early drift of a metric, it can be addressed quite early on.
That's definitely, I agree with you, and especially on the integrated nature of your whole monitoring network. So obviously it has to be specified, extensively enough in the specification that you know that you're covering your critical parameters that you want to cover. But I really think having all of the sensors acting real time, especially on the bigger projects, and reporting to a central system, and someone actually going back and checking what those results are, and obviously you have your typical trigger, action, and alarm levels, but someone actually actively using that data to possibly improve the design or make the necessary contingency measures. That's really critical. But yeah, I fully agree with you, and it's amazing the example that you mentioned about your numerical model, your groundwater model actually being updated as you receive information, feeding that back into the numerical groundwater model. Definitely I'm aware and I've seen cases where you update your numerical model on a bigger project, let's say every 6 months or every year, but what say you update it more regularly. And I think the whole industry is moving towards that digital transformation where, basically it's almost to a point now, especially with AI and I suppose, agentic AI, it's gonna get to a point where all of that is almost automated so that the expert can literally just go and check, has the AI or has the agentic AI done it correctly. But it's exciting times, and I couldn't agree more that you have to incorporate this technology and especially instrumentation and monitoring in your dewatering and shoring design. I think I'm just checking if we have any topics that were further suggested. I think we can open it now for Q&A. We've got about 10 minutes. So yeah, the floor is open. Unless any of the panelists, did you want to add anything, any concluding remarks?
I just, yeah, just fully agree with what Pádraig was saying about that groundwater model being a key. It's not just a key design tool, but you know, it's that adaptive management as your project is going on, and it also touches on environmental factors. You know, we've dealt with sites that are close to environmental receptors, mangroves, and so on. And to understand if you have an evolving impact that you hadn't before predicted, you know, this is why that feedback loop is really important. That's the only thing.
All right. Any Q&A from the audience? Oh, we have a question here. The gent is bringing the mic for you.
Hisham Shadli. Thank you very much for the discussions about a very important topic. And I had hoped if there would have been some examples, I mean, during the discussion, so that it would have brought around more of your experience, guys, to the audience. In addition, I'd like to, entertain ourselves by a bit of technical discussion. I've heard a couple of pieces of information. One was by Savi about the dewatering that brings the water level below the tow level of the shoring system. Of course, logically, it would follow that nearly the shoring system would be irrelevant to water, because if it happened that you're passing below the tow level, then the water curve will diverge from the whole shoring system area. And then Savi mentioned that the absence of the water in the passive zone, which helps the soil, press in resistance to to the pressures coming from the wall, from the passive side. And this is mentioned as a negative effect on the passive resistance. I just wanted, maybe it was just a misexpression. In reality, if you dewater further under the tow, this means, first of all, that you're eliminating the force at first place, that you need not to resist it in the passive zone, because the hydraulic forces coming from the active zone are no more there. Okay? And in the meantime, your passive resistance will still be strong enough, because it will come from pure effective stress. Right? So I just wanted to hint that one, not, I'm sure it was just a misexpression here, not for any of the junior, engineers to get confused. This is number one. Number two, which I believe also it was genuine from Savi to say it, is that the horizontal permeability or conductivity is known in many cases because of the deposition and sometimes because of the heterogeneity to differ at least from the vertical one. And we tend to say it's, in many applications, we find that it is more than the K effect, so the conductivity in the vertical direction. So the issue here was with the specific value of K horizontal equals 10K vertical. Yeah? I'm sure she's speaking about a particular application where it was like this. But I just wanted, as I said, we are entertaining the society, saying that the number 10 is not a rule, right? I could have given this in a, how to say, in a form of a question or something, but I just wanted to make it very, very quick and to take Savi's side on this. Nothing.
Thank you very much. Yeah, and it's definitely good to get your input. You know, especially from a geotechnical perspective. And I fully agree with you that it's very much used in industry, this order of magnitude 10, right? But it's not exactly that always. And it's, you know, in a lot of your shallow soil cases, it's definitely, there hasn't been the geological time passing to have compacted. Naturally, diagenesis hasn't taken place, all of these things that will create that, what do you call it, heterogeneous, anisotropy between your K horizontal and your K vertical. Even if you compact, even through ground improvement, you don't necessarily reach that, because we've done pumping tests where I can tell you, even if the ground is compacted by dynamic compaction, it hasn't significantly reduced the K value in the reclaimed fill. I'll stop there. You guys want to add anything to that question?
That's a good point, by the way. Thank you.
Okay, any other further questions? Oh, we have a question there. There's two questions. One only, sir.
Hi, good afternoon. I'm Namira from Bingati. I just need to ask Engineer Savi that in value engineering angle, if we can using, you know, the shoring design or the shoring method like diaphragm wall can reduce the impact, or the use of extensive dewatering system like heavy dewatering. I'm asking in commercially and technically.
Yes, first of all, technically or commercially, I want to say the safety is important, right? So if you have excessive dewatering and your ground, the purpose of this discussion is like, before you control the groundwater, you have to control the grounds, okay? That can be achieved with effective and integrated dewatering and shoring system together as a geotechnical solution instead of going technical and commercial. Okay, so I always prefer to keep the deep well toe by normally shoring is checked with in terms of stability, and they say the shoring is fine. But again, when we comes to the dewatering, we manage some pumps or wells, and we want to bring the drawdown by putting the walls below the shoring toe, and we want to add more wells, which we are making excessive deep pumping, which will have a huge effect outside the plots, and which will impact the adjacent structures, utilities, and again the shoring itself.
Okay, thank you.
Thank you.
Thank you. Okay, thanks everyone. I think we've done with time. Thank you very much, Dr. Elias.
Thank you very much for your very important and constructive panel discussion. You see some interaction already from the audience. I'm sure that there will be more during the lunch break, because now it's about time to have the lunch break. Please keep the ears a little bit open when the bell will ring again because we have to continue. So thank you for your presence, and we shall resume after the lunch break. Thank you very much.